Okay, in this video, I am going to discuss how a 4-bit adder cum subtractor can be simulated using Verilog Modelsim. First of all, we will see how the program can be created. With an assumption that we have already created one project, and whatever the new profiles you are creating, that need to be associated with the project. That and all you know. With that assumption, I am starting a new program. Okay, now I have already opened the Modelsim. I have opened the file. I am going to create a new file. Go to new, go to source, new, go to source. In the source you have to click the Verilog. A new editor will be opened. Now I have to type the program. Before getting the this is the program. I will show you the program. This is the program of adder cum subtractor 4-bit. Okay, to understand the program, first we will see what is the circuit diagram. You will see the circuit diagram. This is the circuit diagram of a 4-bit adder cum subtractor. Here I am using 4 full adders, and I am using 4 XOR gates to make the B input to be 2's complemented, and then it will be added with A. And already I told you in the hardwares only addition hardware is there. There is no subtraction hardware available in the computer. Okay, the subtraction is carried out only through addition. How it can be done? The number which you need to subtract, that will be converted into 2's complement, and the 2's complement will be added to the number, and then we will get the result, which is actually the subtracted result. Okay, see, there are 4 full adders and 4 XOR gates. This one you kindly leave it right now. Temporarily you please leave it. We are going to implement only this part. 4 full adders and 4 XOR gates. Okay. Now let me take you to the Modelsim. This is the coding. Okay. Module name is add sub underscore 4, and the ports are A, B, in, RES and OUT out. These are the 5 ports. Out of this, A, B and A, B and RES are vector inputs. So input 3:0, A comma B I have given. Similarly, result RES is an output. So output 3:0 RES. Apart from this, there are 2 single inputs are there, in and out. This input in and output out I have declared. Okay, and in the program there are so many wires are there. You please look at the diagram. See, so many wires are there. So I have created many wire variables. Okay, wire T1, T2, T3, T4, T5, T6 and T7. Okay. Now, first of all, this is the program is actually A minus B. The work is A minus B. So whatever the B input, that needs to be converted into 2's complement. Need to be converted into 2's complement. That is achieved through the XOR gate. And if you are actually, if you want to convert this particular circuit to act as the subtractor, you have to give the in input as 1. Okay, in input as 1. I will explain this from the circuit. I will explain it. Okay, if you see, if you keep the in input as, that is C0, that corresponds to in the variable name. Okay, that in input, if you make it as high, then this one along with the B, if both the inputs are, if this is already 1, and if B is equal to 1, the output will be 0. Output will be 0. Okay, that is the 2's complement one. Okay, and whatever this is actually, whenever this is 1, whatever the input you are giving at B0, B1, B2, B3, it is converted into its complement. And 2's complement is nothing but you have to take 1's complement. This we call it as 1's complement. With the 1's complement, if you add 1, it will become 2's complement to the least significant one. If you make the C0 equal to 1, then it will be a 2's complement input is taken for the B. Okay. Coming to this. So what I have done, XOR X3 T3 comma B of 0 comma IN. Okay, XOR gate I have created. The instance is X3, X4, X5, X6, the X6. This corresponds to 4 XOR gates. And for all the XOR gates, the outputs are wires. So I have kept the wires as T3, T4, T5 and T6. And the inputs, one of the inputs are in. That is the carry in whatever you are giving. Okay, in. Okay, and b of 0, b of 1, b of 2, and b of 3 are the another inputs. Okay, so in the XOR gate you are giving this, and you are getting the output in the wires T3, T4, T5, T6. Now the XORed, that is 2's complemented input, is given to the full adder. Okay, so I am calling the full adder function. I have created the instances F5, F6, F7 and F8, and I am passing A of 0, T of 3, T3 in res of 0, comma T1. Okay, full adder F6, A of 1, T4, T1 res of 1, comma T2. Full adder F7, instance is F7, and the inputs are and the ports are A of 2, T5, T2, res of 2 and T3. Full adder F8 is the instance, and the ports are A of 3, comma T6, comma T3, comma res of 3, comma out. Okay, N module. Okay. Now coming to the full adder. This full adder is nothing but the full adder what we have written for ordinary order. So that you can call this function. If you want this particular circuit to act as an adder, what we have to give is in the C0, if you give the carry, the least significant carry that is coming as input, if you make it as 0, then this particular circuit acts like an adder. If you give 1 here, then the circuit acts like a subtractor. Now this particular circuit is actually the coding for the particular circuit is written. Now we want to run the program. We want to run the program. What we have to do? First of all, we have to associate this one, this particular this program, whatever you have written, you have to save it in a particular file, and then you have to associate that file to the project, and then you have to compile it. Once the compilation is over, you have to go to the library tab, and you have to open the work where you could see both the modules. You have to select the add sub 4 module, and for that module you have to simulate it. Once the simulation is done, it will be opening the objects as well as the process window. In the object window, it will show all the variables what are all available in the add sub 4 module, that is A, B, in, res, out. Apart from this, the wires will also come, but out of this only those input and output you want to view, so you have to select only those variables which are your inputs and outputs. You have to give it as wave. You have to add it to the add wave. It's already added. I added it multiple times. Okay, let me remove it. We will select A, B, in, res and out, and I am going to put it in the add wave. Now add wave will be generated. Now we have to give the values. For this, no need to give the inputs in terms of your clock. Instead, you please fix some value. Let us take A is equal to 1010 and B is equal to 0111. Okay, so you have to set the values. Since these are individual values, you have to select the bits individually and you have to set it. Go to the force and set the value. What I decided is I want to give 1010 as my A input. That corresponds to decimal 10. 1010, it starts from here. 3 x, A of 3 is 1, A of 2 is 0, A of 1 is 1, and A of 0 equal to 0. That I have given. Okay. Here you have to open the force, and here you have to deposit 1. Okay, you have to give OK. It's done. Similarly, you have to give the value for A. One value you can give. Similarly, for B also you can give the value. Here I have given 0111 as my input. Okay, as my B input. Now since 1010 is higher than this 111 corresponds to 7. If you subtract, the answer should be 3. This is 10 minus 7. So if I give my in equal to 1, here I have given my in equal to 1. In this case, if I set in equal to 1, what happens? This 0111 is subtracted from 1010 and the answer is 0011. and the carry is also 1, and the carry is also 1. And if I set my input equal to 0, then this particular circuit acts like an adder. That is also demonstrated here in the second timing length. Okay. First one is, since I have taken the run length as 300 picoseconds, and since I am depositing the values one by one, and I am running the program, first 300 is meant for, I did it for subtraction, and second 300 I did it for addition. Here I made my in equal to 0. See, look at here, I made the in equal to 0. Okay, and my A is equal to 1010 and B is equal to 0111. If I add these two numbers, my answer will be, my result is 0001, that is my sum, and my Cout equal to 1. My Cout is equal to 1. Okay, in this way you can check different values and you can get the output.